Good morning, Trig. I've been sitting here staring at my computer for 15 minutes, trying to think about the best way to launch this. We're graphing tangent today, and I finally just hit record. I'm like, let's just go for it. Let's do it. So to graph tangent, we're going to start the same way that we graphed sine and cosine, which was the cardinal direction. So those easy ones, the 0, pi over 2, pi, and so on and so forth. And where we were doing the y-coordinate for sine and the x-coordinate for cosine, we're going to do the y-coordinate over the x-coordinate for tangent. So without further ado, let's take a look at that, and hopefully I'm trying to do some different things with screencast-o-matic today. Hey, there it is. So there it is. We're doing tangent today. We're in 4-6. We're finally out of 4-5. 4-5 was all graphing sine and cosine. We want to start by going around the circle. So at 0 degrees, what is the tangent? Okay, the y-coordinate over the x-coordinate, it's 0. Okay. Up at 90 degrees, y-coordinate over the x-coordinate, whoa, we can't do 1 over 0. It was undefined is how we've been putting that. What will that look like on a graph? Well, we're going to find out today. The next one, y-coordinate over the x-coordinate, 0, y-coordinate over the x-coordinate, undefined, and back finally to 2 pi, the y-coordinate over the x-coordinate, back to 0. So we get this little table here. And this little table doesn't do us enough. It doesn't give us enough information. I got some zeros and I got some things that I don't know what they are. They're not defined. So let's take a look. I found a little applet that we can manipulate and kind of look at and see what's happening with tangent. So remember, here's the unit circle. As I move this yellow dot around the unit circle, we're looking at what's happening to the y-coordinate over what's happening to the x-coordinate. So I'm going to hopefully, right off the bat, we start at 0 degrees. The tangent was 0. If I just move this theta a little bit, 9 degrees it says, my y-coordinate now is a tiny number. My x-coordinate is a number really close to 1, but not quite 1. So hopefully you guys can see my calculator up here. Let's do a tiny number, 0.01. So there's my y-coordinate, divided by my x-coordinate, which is pretty close to 1, but not 1, 0.9. And we get something really small, pretty close to 0. And that's where tangent is. It can't jump around yet. Okay, we're at 0. I moved up to 9 degrees. Now it's a little bit more than 0. So I'll keep moving that. We actually have one easy number to work with, and that would be 45 degrees. The tangent of 45 degrees is 1. So it started at 0. It's increasing to 1. Now we get, as we approach this undefined, it was undefined at pi over 2, this is where we get into something different. If I get pretty close to it, like right here, looks like my y-coordinate is pretty close to 1, maybe 0.9, and my x-coordinate is pretty small, maybe 0.1. So on my calculator, 0.9 divided by 0.1, that's 9. Okay, it's bigger. It's getting up there. Maybe it's up to 9. Okay, as I get even closer, though, I can approach this 90. What if I was right here? Wow, okay, so my y-coordinate is really close to 1, maybe 0.99. And my x-coordinate in that case, if I drew my little right triangle, I have a tiny little x-coordinate, maybe at 0.01. That would be 99. Okay, that's way up there. That's flying up there. Okay, well, I can keep getting close to this undefined, as close as I want to, and I can do something like 0.99999, really close to 1. Right? As soon as it gets to 90 degrees, it's 1. So if I'm not quite there, it's really close to 1, but not 1. And I'll divide it by, well, my x-coordinate would be tiny, really, really close to 0, 0.000001. Okay, where's that going to go? Whoa, it blows up, okay? The closer I get to 90 degrees, the closer this thing approaches to infinity. Okay, this thing is going off to infinity. It's approaching this line. It's getting close to this line, but never quite getting there. That's the definition of an asymptote. You remember an asymptote from your Algebra 2 days. And that's what's happening here. These tangent graphs are going to have these points that they get really close to, but never quite get there. Okay, so right at 90 degrees, it's undefined. It's nothing here. Tangent doesn't exist here. Now look what happens as soon as I slip over into this second quadrant, like 91 degrees. If I slipped over to the second quadrant, the y-coordinate's going to be really, really close to 1 still. Like if I'm just right here and I drew my little right triangle up here, it would be 0.9999. But my x-coordinate now is really, really small, really close to 0, but in the negative direction. Negative 0.00001. Okay? Now, this thing, this asymptote, so there would be a dotted line right here. It jumps down from being positive. I said it doesn't jump earlier. Here it does jump. It's really, really positive up here. And then as soon as I go right on the other side of 90 degrees, it jumps down into the negatives. It's actually way down there now. And as I move this closer, it's getting closer and closer to 0 until I finally get to 0 at pi radians. Okay, so this is one period of tangent. This is what tangent looks like. Pretty funky looking. We have what's called inflection points. That's what we're going to call these. Right now they're x-intercepts right here at 180 degrees and 0 degrees, but they don't always have to be x-intercepts, so I don't want to call them that. Inflection points mean they're changing what's happening with the slope. So in this case, the slope is really, really steep, but it's getting less steep, less steep, less steep, less steep, until this inflection point, and now all of a sudden the slope starts going to get steeper and steeper and steeper and steeper. So we call them inflection points. We have inflection points. We have vertical asymptotes. Those are those lines that we're getting really, really close to, never quite getting there. And then we have what hopefully we're going to use pi's over 4, because tangents of any kind of pi over 4 is either going to be a 1 or a negative 1. Thank you, bell work. Okay, so let's take it back to the notes then, and we'll hopefully hammer this home. This is not going to look like sine and cosine for us. There are different methods. There's different tricks to doing this. Looks like it's in focus. Good. So this is where we're at. We're going to have inflection points. We're going to have vertical asymptotes. So far, with tangent, with that little table, if I just put the information we just found on that table, we would have this. Okay. Vertical asymptotes where it was undefined. X-intercepts are zeros in this case at those inflection points. So we need more data. We need another point. What's going to happen with all vertical asymptotes is it has to approach it going up, like get really, really positive, like this way, really blow up going up this way, or blow up going down, negative. It has to get really, really negative. And we don't know which one. I need to know, is this thing going to go up or is this thing going to go down? So what we need is one more point, one more data point to put in there. And the one we're always going to use, again, if you follow these instructions, will be pi over 4. Something you wouldn't need a calculator for. We can take the tangent of pi over 4, that's 45 degrees, 1 square root of 2, tangent of that would be 1. So we need to figure out what these are. So we get this other bell work question that comes to mind. I need to find out what's halfway between pi over 2 and pi. Well, half of pi is pi over 2, half of pi over 2 would be right here. It's 1 pi over 4, 1 pi over 4, 2 pi over 4. This is 3 pi over 4, 4 pi over 4, 5 pi over 4. 3 pi over 4 and 5 pi over 4. I need to take the tangent of those. So we need more points, we need more data. So we need to find those halfway points. Halfway points between an asymptote and an inflection point should always be put us on pi over some form of pi over 4. So we find those. This is the little table we fill out, 3 pi over 4 and 5 pi over 4. Let's go ahead and figure that out real quick. Okay, so 4 pi over 4, back it up 1. Here's 3 pi over 4. 1, square root of 2. But this one's negative. So the tangent at 3 pi over 4 would be negative 1. How about 5 pi over 4? Okay, that's negative 1, that's negative 1, that's square root of 2. Tangent at this one at 5 pi over 4, that's a positive 1. Okay, so we filled out our little table. We now have points that we can put in here. We get a 1 and a negative 1. Should look something like this. At 3 pi over 4, we got negative 1. At 5 pi over 4, we got positive 1. One thing, a little trick here to drawing these, you guys, don't put the 1 really, really high. If you put whatever your first point is, and when we're trying to figure out if it goes up or down, if you put it really, really high, drawing these is tough, because we know it has to go through this point, it has to go through the point we just found, and then it has to approach this asymptote, but never quite get there. If this point is really, really high, trying to draw that goes like off our paper by the time we finally get to the asymptote. So make these, scale these, pretty small, close to the x-axis. Okay? So there's one period. So we just graph tangent. This is what tangent looks like. We have 2 consecutive asymptotes, an asymptote, an asymptote. We found the mid-halfway point is going to be our inflection point. And then we found a quarter point, or another halfway point, to figure out if it goes up or if it goes down. And all tangents are going to work this way. If you find one of them going up on one direction, it's going to go up this way. It has to go down the other direction. It's not going to turn around and go back to the asymptote the other way. Tangent won't. Something else might. This says neighbor talk. What is the period of y equals tangent x? How long does it take until it repeats itself? So I can kind of go back to that GeoGebra thing. We went halfway around the circle. See if I can do it delicately. Sure. So halfway around the circle, right now it's at an inflection point on its way up. On its way up, blows up, starts over in negatives until it gets to an inflection point. There, stop. And now it's at an inflection point on its way up again. This is one period of tangent, and tangent repeats itself every pi unit. Look, we only went halfway around the circle. So where sine and cosine had a period of 2 pi, tangent only has a period of pi, which also gives us a little formula. If we want to find the period of pi, instead of going 2 pi over b, like it was for sine and cosine, it's just pi over b. Pi over b will give us the period for tangent. Okay. Take it back to this thing. We're probably going to need 2 videos for this. So I will mention this. This is one period of tangent. If I want another period, I could just continue this pattern again, and I can draw another asymptote, 3 consecutive asymptotes, 1, 2, 3, and I could just repeat that shape, because we know it's periodic. It's going to happen again. But the book won't do that. The book will actually use this inflection point, this inflection point, and this inflection point, and only 2 asymptotes. And it's a little bit different. It looks a little bit goofy, but it gets the job done. Back up a little bit here. This is what the book would tell you y equals tangent x looks like, 2 full periods. They still got the middle one that we got, but then they would put a little half period here and a little half period here. And that's okay. And that's probably the way I'll do it too, since the book does it that way. And it's a little bit easier. One thing we can notice, if it approaches going down on one side of the asymptote, it's going to approach going up on the other side. So we don't have to do a bunch of different points, like with sine and cosine. We can do pattern recognition, and we're going to when we do this. We filled in 5 pi over 4 and know that was going to go up, and that was all I needed. Once I found just that one point for 5 pi over 4, I knew that it would approach up going this way. It would approach going down this way. If it was up here, it would have to go down here. If it was down here, it would have to go up here. 2 full periods. So you don't have to find every single one of these quarter points to graph 2 full periods of tangent. We're going to make use of some pattern recognition and just find one of them. Does it go up or down? And that should tell us enough. Okay? That's video 1. Tangent's crazy, and I was a little long-winded, but that's okay. So come back, watch video 2 we'll do some examples together, and then that'll be it. I'll give you your stamp. All right, moving on.